Let's analyze the physics of a chain lying on the ground. We have a chain that is 10 meters long with a mass of 80 kilograms. We'll explore concepts like linear density, potential energy, and the equations of motion when lifting the chain. First, let's understand linear density. Linear density is the mass per unit length of the chain. In this case, we have 80 kilograms distributed over 10 meters, giving us a linear density of 8 kilograms per meter. Let's visualize our chain lying on the ground. Each meter of the chain has a mass of 8 kilograms. We can think of it as being divided into segments, with each segment contributing to the total mass and potential energy when lifted. Now, let's consider what happens when we lift one end of the chain. The potential energy of any point on the chain depends on its height and the mass of the chain up to that point. As we lift the chain, each segment gains potential energy based on its height above the ground. When analyzing the motion of lifting the chain, we need to consider two key aspects: the changing mass being lifted and the varying force required. The force required at any point is equal to the weight of the lifted portion plus the rate of change of momentum of the chain being lifted. The principle of conservation of energy tells us that the work done in lifting the chain equals the total potential energy gained. The work done is the integral of the force over the distance, while the potential energy gained is determined by the final height of each segment. To summarize, our 80 kilogram, 10 meter chain has a linear density of 8 kilograms per meter. When lifted, the potential energy and required force change continuously due to the varying amount of chain being supported. Understanding these concepts is crucial for analyzing the dynamics of flexible, extended objects like chains.